function f is defined as r minus singleton 0, that is this function is defined from r minus singleton 0 to r, given by f of x is equal to 1 upon x minus 2 upon e raised to x minus 1, can be made continuous at x is equal to 0 by defining f of 0 as, means we have to find the value of f of 0. Therefore, limit x tends to 0 of f of x is equal to f of 0, means we find this value of limit, which is nothing but our f of 0, as function is continuous. Therefore, we find this. Then limit x tends to 0, f of x is 1 upon x minus 2 divided e raised to x minus 1. If we take cross multiplication, then what we get, that is 1 minus e raised to 2x, this into this, this as 1 into this, that is e raised to x minus 1, 1 into this, and minus time, that is 2 into x, that is 2x, divided by denominator term is x into e raised to 2x minus 1. Then using the expansion of exponential term, we know that the expansion of exponential term is that is e raised to x expansion is 1 plus x square plus, using this e raised to x expansion, that is e raised to x expansion is 1 plus x square upon 2 factorial plus x cube upon 3 factorial. Then when e raised to 2x term is there, okay, that is we write expansion of this e raised to 2x. When e raised to 2x term is there, then in place of x we have to write 2x, that is 1 plus 2x square upon 2 factorial plus 2x cube upon 3 factorial, okay. Then using this, that is we get here expansion of e raised to 2x term as, that is e raised to 2x expansion 1 plus 2x, then plus 2x square upon 2 factorial, 2x cube upon 3 factorial, plus dot dot dot, last term is here minus 1 minus twice x, and divided again denominator term, but before this we simplify numerator term, this term and this minus get cancelled, that is remaining is only numerator as 2x square divided 2 factorial plus 2x cube divided 3 factorial plus dot dot dot, and denominator is our, that is x into e raised to x minus 1, that is again expansion of e raised to x is 1 plus 2x plus 2x cube divided 3 factorial. Continue this way, last term is here minus 1, that is e raised to 2x into e raised to 2x minus 1, okay, last term is minus 1, means this minus 1 and this plus 1 get cancelled. After that multiply this x inside, means numerator term 2x square upon 2 factorial plus 2x cube upon 3 factorial plus dot dot dot, denominator term is 2x into x means 2x square, next term is 2x square, that is square into x upon 2 factorial, next is 2x cube upon 3 factorial into x, continuing in this way. Then this 2 factorial is multiplicative to this 2x square, okay, that is numerator term is this as 2x square, denominator term is 2 factorial into 2x square, means what, that is 4x square divided by 4x square. The next term is also 2x cube, and this one, that is dividing each term separately. Therefore, finally we get the simplification of this e raised to 2x minus 1 minus 2x divided denominator term x into e raised to 2x minus 1, and limit x is tending to 0, that is e raised to x expansion minus 1 minus 2x, here we have cancelled out this e raised to 2x expansion, and then minus term also we have cancelled out, denominator is x into e raised to x minus 1. Then after that simplifying this, remaining term is 4x square divided 4x square. Then when we take the limit x is tending to 0, that is this x square get cancelled, and then we get 4 upon 4, that is 1. The answer is 1. Therefore the value of limit is 1. Then the next one example is there. Here, let f of x is equal to defined function 1 minus sin x divided pi minus 2x square when x is not equal to pi by 2, and when f of pi by 2, that is when x is pi by 2, value is k. Then find the value of k which makes f continuous at pi by 2 is. That is here, when function is continuous at x is equal to pi by 2, we have to find the value of k. That is limit x tends to pi by 2 f of x when it is continuous, when it is equal to f of pi by 2. then we find this value. Therefore limit x tends to pi by 2 of f of x 1 minus cos x 1 minus sin x divided by pi minus 2x. Then here we substitute x is equal to pi by 2 plus h. Then when we substitute x as a pi by 2 plus x, that is we get sine of pi by 2 plus h, and then we expand this by using sin a plus b formula, that is sin pi by 2 sin a cos b, that is cos h plus cos pi by 2 into sin h. But cos pi by 2 is 0, means this second term becomes completely 0, and sin pi by 2 is 1, means only cos h. Therefore we get here limit here h tends to 0. H is tending to 0 because we have substituted x as a pi by 2 plus h. H is tending to 0, 1 minus cos h divided by denominator term is, after substitute x as a pi by 2 plus h, that is pi minus 2 times pi by 2 plus h. Okay, then simplified term limit h tends to 0, 1 minus cos h divided by this, multiply this 2 inside, pi minus this 2 and this 2 get cancel, and remain is minus 2h, pi minus 2h. Yes, this pi minus, that is here simplified term is pi minus 2h. This and this get cancelled, remaining only minus 2h is there. Okay, then after that, that is we simplify this 1 minus cos. Here simplified term pi minus 2x, here square is this one, therefore simplified term of pi minus 2x is minus 2h, and its square means minus 2h square. Therefore limit h tends to 0. This 1 minus cos h means by using half angle formula 2 sin square h by 2. Denominator term is this as minus 2h square means 4h square. Out of this 2 get cancelled, remain is limit h tends to 0. So numerator term is sin square h by 2, denominator is only 2h square. Then in order to apply the standard result of, that is limit theta tends to 0, sine of p theta divided by p theta is equal to 1. Then whatever the term of p is present, same thing term is must be here. But here we have limit h tends to 0, we have the term limit h tends to 0 sine square h by 2, sine square h by 2, and denominator is 2h square, means here h by 2 or the sine square theta, that is same thing as sine theta square. Okay, then we write this value as sine square h by 2 as limit h tends to 0, this sine square h by 2 means sine h by 2 square, and denominator we have 2h square, means we want h by 2 square, that is 2h square is there. Then we want here divided by 4 multiply, that is we want here h by 2 square means divided by 4 into 4. Okay, therefore we write this term as limit h tends to 0, this sine h by 2 divided this h by 4 square means h by 2 whole bracket square into remain is this 2 and this 4 means 1 by 8. Okay, and this term by using the result sin p theta upon p theta is 1, means sin h by 2 divided h by 2 square, that is 1, remain is only 1 by 8, that is value of limit is 1 by 8. Okay, therefore option first is correct, 1 by 8. Then next one example is that the value of k which make the function defined by f of x sine 1 upon x if x not equal to 0 continuous at x is equal to 0, and when the value of function is k when x is equal to 0. That is we have to find the value of k which make the function defined by this one is continuous at x is equal to 0. That is we find the value of k such that this function is continuous, means at x is equal to 0, means when it is continuous, if it satisfies the condition limit x tends to 0 f of x is equal to f of 0. That is we have to show that these two are equal, then this function is continuous. And then here when we find the limit x tends to 0 of f of x, limit x tends to 0 f of x is sine 1 upon x, but here 1 upon 0 is infinite term and it does not exist. Okay, that is this limit does not exist, means none of this function is not continuous, that is it does not exist, that is it is not continuous.